All right. Another video dealing with Hess's law. This one deals with specifically the topic of standard enthalpy of formation. And so not much to explain. Let's get stuck right into it. So standard enthalpy of formation is obviously dealing with things in their standard state. And so standard state is the state at which a substance is stable at 101.3 kilopascals. That's 1 atmosphere and 25 Celsius. Okay, and so the standard enthalpy of formation is defined as the amount of heat absorbed or evolved when specifically 1 mole, and that's important, 1 mole of the substance is formed at 25 degrees in 1 atmosphere from its elements in their standard states. That's also important. Now this is sometimes referred to as standard heat of formation. So enthalpy of formation, heat of formation mean the same thing. So I'll just quickly show you another little video that maybe gives you an idea visually of what a standard enthalpy of formation looks like. So here we go. Okay, so just a quick little video hopefully to outline enthalpies of formation. Elemental carbon, carbon solid, elemental hydrogen, H2 gas. And so if I put these two compounds in their elemental state together, and if I can generate a reaction, I'm going to produce a new product, a new molecule. So I'm going to do that. I'll do that in the bowl just to keep the mess down a bit. So there they are. They're interacting. Oh yeah, that's looking good. They're combining. Oh, and I think we're done. And so now that is my product. And so my product is methane, CH4, that originated from 1 mole of elemental carbon and 2 moles of elemental hydrogen, hydrogen gas. And that is how enthalpies of formation work. So hopefully from that you can see that we are talking about the formation of 1 mole of substance, that's methane, from its elements. The elements that make up methane are carbon and hydrogen, so elemental carbon, carbon solid, and elemental hydrogen, H2 gas, are what form 1 mole of methane. All right. Now, just a couple of things to make sure. If it is, you have to make sure you understand or appreciate what standard states refer to. So let's use oxygen as an example. So in its standard state, it exists as a gas only. And so that's at 25 degrees, 1 atmosphere. Oxygen gas, O2 molecules, O2. So oxygen atoms, oxide ions, and ozone molecules are not representative of oxygen in its standard state. And furthermore, if you had liquid or solid oxygen, it is also not representative of oxygen in its standard state. Remember, oxygen is a gas under standard conditions. Now, very extensive tables that report standard enthalpies of formation. So you'd be given these tables, you just have to make sure you know how to use them. So again, we're interested in this column here, delta HF naught. Remember the naught means standard, and that's in units of kilojoules per mole. And so just draw your attention to a couple down here at the bottom, carbon monoxide, carbon dioxide. We're going to see those in a minute. And so basically enthalpy of formation of carbon monoxide, negative 111 kilojoules per 1 mole of CO formed. All right. Now, you don't have to get too worried about this. It's just another enthalpy term. It's just specific formation of compounds from their elements. And that specificity also extends to formation of 1 mole of the compound. So 2 things you want to be able to do, and we're going to do the first one today. Write thermochemical equation for the enthalpy of formation, including the delta H term. The other thing I want you to be able to do is be able to solve enthalpy of reaction questions using delta HFs, but we'll cover that in the next video. So again, let's plow on. Now, you might want to pause this in a minute, and if you need to, copy it down. But this is a good order of things as far as I can tell, to be able to write a thermochemical equation for an enthalpy of formation. So first thing is write the formula of the compound. So this is where nomenclature comes back, and remember back to grade 11. Now the compound is always the product. So you're going to write that on the right-hand side of an arrow, right-hand side of the page, with an arrow pointing to it. Then you're going to write the formulae of all elements. And these are, again, in their standard states. and these are always reactants, and so they're going to appear on the left-hand side, so on the left-hand side of an arrow leading to the products. And then you're going to simply add the thermochemical term as part of the equation. In all likelihood, you're going to have to look this up. But finally, don't forget, you have to balance the equation, okay? And this becomes important because you're going to see in many instances, or some instances, we have to have fractional coefficients. In some instances, many instances, you do have to balance the reactants. You can't balance the products because they're going to be balanced as written, 1 mole of product. All right, let's try a few. So with this one, write an equation that represents the standard enthalpy of formation for carbon dioxide. So product, CO2. And it's a gas under standard conditions. Now I already looked up the delta HF for this, so I'm going to just write it right away. It in fact is negative 393.5 kilojoules. 393.5 kilojoules. And that's per 1 mole of CO2 formed. Now, what is CO2 formed from? Elements in their standard state. So the element carbon plus the element oxygen, O2. Remember, molecular oxygen is elemental oxygen. Now, balance it. So we check the balance. I have 1 carbon and I have 1 carbon. I have 2 oxygens, I have 2 oxygens. So that's balanced as written. And that happens occasionally. But you still need to check. All right. Now, how about carbon monoxide? So I mentioned carbon monoxide. So carbon monoxide, CO, it's also gas. It's the product, and it is also formed from carbon and molecular oxygen in the gaseous state. The delta HF for carbon monoxide is negative 111 kilojoules per mole. And so now I have to check that it's balanced. And so I have 1 carbon, 1 carbon. I have 2 oxygens. I have 2 carbons, 1 oxygen. And so I'm just going to write a 2 there. Then I have to balance the carbon. Now it's balanced as written. The problem here, though, is remember the definition of a standard enthalpy of formation is that it's 1 mole of product. So I can't balance the carbon. I can only change the reactants, and that's what I was referring to earlier. 1 mole of carbon as written, you can't change that. So I'm going to erase this. So that leaves me with only really 1 term to balance, the oxygen, because the carbon's already balanced. And so how do I make 2 oxygens equal 1? I multiply it by 1/2. And now I have 1 O on the left-hand side, 1 O on the right. So this is what I meant, fractional coefficient. They're pretty common. Be ready to have to use them, fractional coefficient. Okay, one last one. Let's have a look at this one. So write the enthalpy of formation for calcium phosphate. Well, here's the compound, calcium, charge of 2, phosphate with a charge of 3. So I have 2 of them, and that's a solid. And what's it formed from? Well, it's formed from calcium solid. It's formed from phosphorus, which is also solid, and it's formed from oxygen, which is a gas. Now the delta HF, again, I looked that up already, and it was negative 4126 kilojoules per mole. So that's a big delta HF, 4126 kilojoules. Now I need to balance it. And so 3 times calcium, 3 times calcium. 2 times phosphorus, 2 times phosphorus. I have 8 oxygens, so 4 O2. So that's a balanced thermochemical equation for the enthalpy of formation of calcium phosphate. And that's all there is to enthalpies of formation in this first video. We'll learn how to use them in the next video to answer enthalpy of reaction questions. But for the time being, that concludes this video.